Here we are with section 3.2, angles formed by parallel lines and transversals. Our objective, I can prove and use theorems about the angles formed by parallel lines and a transversal. What we'll be doing here is we're looking at one specific situation, and that specific situation is when we have parallel lines cut by a transversal. Remember that transversal is a line that cuts through two other lines. So we're going to, for each postulate or theorem today, we're going to deal with the same situation, parallel lines cut by transversal. Here's our first one, corresponding angles postulate. You'll notice the hypothesis is if two parallel lines are cut by a transversal. We will see that in each of our postulate and theorems today. All this is saying is if we have this situation, parallel lines with a transversal through it, our corresponding angles are congruent. So we know 1 and 3 are corresponding. They're in the same general location. They're both top left of that group of 4. The top left of this group of 4 and of this group of 4. They're in the same general location. Those are corresponding. So we know that those are congruent due to the corresponding angles postulate. So using that, we can find the angle measure. So if we're looking for ECF, so ECF right here, that's going to be congruent to the other corresponding angle. So since the other corresponding angle, GBC, is 70, then ECF has to be 70. Corresponding angles are congruent. So if we're looking for DCE, that angle is corresponding to this angle. So we can do 5x is equal to 4x plus 22. You subtract your 4x over, we get x is 22. And once you plug it back in, we get our answer of 110 degrees. I want you to try it. What is QRS? Be careful before you just jump to an answer. Alright, so if you said 118, you are not correct because you didn't look at what they were asking for. They're asking for QRS. They're not asking for what x is. So you find x by using corresponding angles, but then our definition of a linear pair tells us that we have to subtract that from 180. Once we do that, we are going to get 62 degrees for QRS. Here's a hint. If a transversal is perpendicular to two parallel lines, all 8 angles are congruent. They're all 90 degrees. So that's the only time where you will have all 8 angles being the exact same. Again, just a reminder, we've got postulates and theorems. Postulates are statements that are accepted without proof. That corresponding angles, that was a postulate, which means we can use that to prove other things. So we're going to use that to prove our next 3 theorems. We're not actually going to walk through that, but we could if we wanted to. So the next 3 are theorems. So here are our 3 theorems. We've got alternate interior angles, which we can abbreviate AIA. That tells us alternate interior angles are congruent. 1 is congruent to 3, and 2 is congruent to 4. We've got alternate exterior angles theorem, AEA, which tells us that our alternate exterior angles are also congruent. And then we've got same side interior. Same side interior is the one that's different because we're not talking about congruent anymore, we're talking about supplementary. So 2 plus 3 equals 180, 1 plus 4 equals 180. If they're on the same side and interior, they are supplementary. They add up to 180. Okay, if we want to find each angle measure here, we're looking for EDG first of all. So if we're looking for EDG, we're looking for this angle right here. Well, what we know is alternate exterior, that's got to be congruent to this angle. So that has to be 75 degrees for EDG. And when we're looking for BDG, now we're looking for BDG, we have x. Well, I could say x plus 2x minus 135 is equal to 180. I could do that. I could set up x minus 30 is equal to 75, figure out what x is from that equation because of alternate exterior. Either way is going to be fine. If I set that up, that first one that I said, 2x minus 135 plus x equals 180. Those are same side interior angles. They add up to 180. I can combine my like terms, add the 135 over, divide by 3, and I get 105 degrees for x. Or as I said, you could simply set up x minus 30 is equal to 75, alternate exterior angles, and solve that for x. You get 105. Okay, I want you to try it. Find measure of angle ABD here. Just so you are aware that 2x plus 10, that is ABD, 3x minus 15 is BDE. Alright, so Alternate interior means that they are congruent, so we set them equal. We solve it all out. We get x is 25, but they're not asking what x is. They're asking what ABD is, so we got to plug that back in. Plug that back in, and we get 60 degrees for that answer. Okay, lesson quiz. Pause it, try it, come on back, see if you got it right. Alright, so for angle 1, alternate exterior angles theorem helps us to say that measure of angle 2 is 120. Right? They are congruent because they are alternate exterior. For number 2, 2, and 3 are corresponding. So those are, again, congruent, so we can set them equal and then solve it out and plug it back in. We get 120. 3 and 4 are alternate interior, so again, those are congruent. Set them equal and then solve for x, plug it back in. 3 and 5 are same side interior, so they're not congruent. They are not equal. They are supplementary, so add them up, set it equal to 180, solve for x, again, plug it back in, and we get it. That's our lesson quiz. Not a lot to it. We just need to know, first of all, what those corresponding alternate interior, alternate exterior, same side interior angles are. That's from 3.1. Now we're just saying, what can we say about it? And remember, this is only in one specific situation. This is only parallel lines cut by transversal. If you don't have parallel lines, you cannot use this postulate and these theorems. So that's it for section 3.2.